Hi. Good morning. Welcome to the last day of the conference. Oh, no, that's still great. So as the intro slide mentioned, I'm an engineering director at Google. I manage the Angular team, but also a lot of other teams that build developer tools that are used across the entire company. And we're going to do this presentation in two parts. First, I'm going to talk a little bit about how we use Angular at Google, some stories you probably haven't heard, and how we view open source software in general, and why this is important to how we work together inside and outside of Google. And then Rob's going to come up and talk about some new uses we're seeing some of you come to us with for the Angular platform and ways that you folks are using it outside of Google. So, inside Google, we'll talk about how we use Angular, the types of projects we use it on, and a little bit about our development platform. And then why open source? Why do we take the trouble to push our software outside of Google and collaborate with a ton of folks that we wouldn't normally otherwise interact with? To put it simply, the business of Google actually runs on Angular. And by what I mean by that is that overwhelmingly, the teams that build internal and external software pick Angular for the developer productivity reasons that I think a lot of you pick and why you come here today. Just as some examples though, you actually can't get a product approved and launched at Google without going through an app written in Angular. You actually can't get hired at Google without using an Angular application. You can't get promoted or even paid without using an Angular app. You can't even file a bug without using an app written in Angular. These and hundreds of other apps, all written in Angular, originally written in AngularJS and now moving to Angular. And as Steven said on the first day, it's almost 200 of these apps currently running on Angular. We're working really hard to make sure that all of them can migrate quickly, upgrade quickly, and that we want all of the development to happen on Angular by the end of 2017. We're doing some things internally to make this possible. First, we've got some automated tools that we built to take our current version of JavaScript, which is called Clojure, and migrate it to TypeScript. We've actually been doing typed JavaScript at Google for over a decade now. I'll talk more about this in a few minutes. But we've built some tools to make this an easy process. Just recently, we made it so that Material 1 and Material 2 components could work together in the same application. And so you folks, externally, if you've taken advantage of Angular Material, you can have the same advantage. And then lastly, we built a couple courses to help developers learn about Angular. You know AngularJS? Moving to Angular, we built some courses to help you do it. The response on this course has been phenomenal, and far beyond what we could satisfy with the Angular team. And so 59 other software engineers at Google volunteered to step up and teach these courses in 19 offices around the world to over 3,000 Google attendees. This is an amazing number, not just because it's large, but for another reason I'll tell you in just a little bit. Hold the surprise. Not just internal applications, but a ton of the public-facing big applications are written in AngularJS and are now also upgrading to Angular. Some things like Cloud Platform, Google Analytics, Firebase, Google Shopping Express, and others. And since we're at an open source conference, if you want to check out an application that was written in Angular from scratch, you could actually go to our opensource.google.com page, click on the projects directory. You can see the snazzy Explorer so that you can go through actually all of the projects that we open source at Google. But why do we do it? So we talked about how Google uses Angular, but why do we do it in the open source? It might be simpler if we just did it internally. Well, just a little bit of history here. There's a whole bunch of projects that we have not open sourced, some things that we've used at Google to make software work at scale at very high performance. Things like MapReduce to help us transform data from one form to another, data persistence and reporting tools like Bigtable, Dremel, Spanner, and then the ways that we manage our data centers with the Borg software. We didn't open source these, but we talked about them. And so what happens is that people outside of Google build open source versions of these. Where I had MapReduce, I have Hadoop. When I had Bigtable, we have HBase. It's actually not a problem in and of itself, but we actually miss out on some advantages that we could have. So when we do open source, however, we get some advantages. One is we kind of get credit for it. That's kind of nice. It is kind of important to be seen as a technology leader when we're trying to attract talent to Google, and we do want to do that. But when we release a software product, it's not just that tool, but it's an entire ecosystem of tools. And so for Angular specifically, we get to take advantage of a whole community. All of you, like many of you, actually contribute to the community with things like linters and IDE extensions and all kinds of other things that work with the Angular system to make it a beautiful environment to work in. Training. We built our own training course for how to build Angular applications at Google, but it's far bigger than that. Google engineers actually use egghead.io and come to conferences like this one that we would never have if it was just an internal-only tool. For hiring, it's very, very important that Google not just be built on proprietary software solutions. Because if we are, then when people come to Google, there's a big ramp up to become productive on a team. If you can come in knowing technologies that we use at Google, it's so much easier for people to become productive on a team. And then lastly, we get some enormous quality benefits by just seeing all of the use cases that folks outside of Google bring to us versus just the ones that we would have internally at Google. So we have all of those benefits, and so we want our solutions to work inside and outside of Google. But I'm going to go through a couple of these things, and some of the answers might surprise you. So of course, Angular, this is something that we use inside and outside of Google. TypeScript, however, until as of February, was not something that we could use inside Google. I'll tell you why in a minute. And then the CLI, also not something that we can use inside of Google, and we'll explore that too. All right, so on language, there's actually just a small set of what we call the canonical languages at Google that we're allowed to use. And the set is C++, Java, JavaScript with an asterisk, Python, and Go. And the reason for this is pretty simple. Like, we want to have an environment where if I'm an engineer at Google, I don't have to learn 15 different languages to be able to edit software projects across Google or to move from one project to another. So it's really a good thing. And so that we can build one set of tools that can operate on these languages at scale, that can help us be productive at Google. Now, I put JavaScript with an asterisk here because it is JavaScript, but probably not the JavaScript that you're used to. Here's an example. So this is closure-style JavaScript, where we can see at the top we've got our own module system, we've got a format for defining classes, and maybe the most striking thing is that we do types in comments. Now, Clojure is open source. Some of you actually use the Clojure system. Some of the folks externally have used this. It might be familiar to you. But we on the Angular team, we wanted something a little bit more ergonomic than this. We've been using this for over a decade. It's been working very well for us. But we wanted something different. So if you remember at previous conferences, we've done crazy things on the Angular team. Like, we were going to go write our own language. We built this language called AtScript. We collaborated with folks on the Chrome team, building on top of their transpiler. We were going to extend the JavaScript language with formal class syntax, like we see in ECMAScript 2015, adding metadata operators so that we could describe the way we do dependency injection, and some other stuff that we just thought would be nice in the language. We all know how this worked out. We ended up collaborating with Microsoft and getting all the things that we wanted out of AtScript in TypeScript. Beautiful, because again, we didn't have to do it. There's a huge community around TypeScript, and we can just all contribute to one thing. But that didn't mean we could use it at Google. Wonderful solution on the outside. We were developing Angular in it because it was done in the open source, not a problem, but we couldn't use it on projects inside Google yet. And just a little bit more to drive home the motivation why we wanted to do this. If we take that same example in Clojure and translate it to TypeScript, we notice, number one, with inline types it becomes so much more readable. It's easier to type and easier to read, and I read software a lot more than I write it, so that's super good. We get the IDE benefits, and there's some other things. We'll talk about what other benefits we wanted to get out of it. Well, lucky for us, there is a process for getting new languages approved at Google. And it kind of goes something like this. You would apply to say, I want a new language. You would go through this checklist, kind of long, multi-page document, where it says that, well, you should build compatibility with all of the other software and process layers at Google first. Then go get some guinea pigs, some field trial people. Some of them are here today with me. Thank you. Hi, Scott. And you would prove out that this new language had benefits over and above the existing languages as a rationale for why would we bring this into Google. We would then go to the committee and we'd be approved. Seems simple and straightforward, right? The thing we didn't know was nobody had ever done this before. All of those languages I showed on that previous page were done by fiat. Some vice president at Google had said, we will have language X. I'm not a vice president, so I wasn't able to do that. So I went through this process. And what it meant was that we ended up going through a couple loops to the committee, and they would decide, well, really what we want to see is this. It took a little while, but we were persistent. And I'm really happy to announce externally that for the first time, any team at Google can come and sign up to use TypeScript on their front end as an approved language at Google. Now, just for full details, we're managing this. You actually have to sign up on a whitelist. There's a couple things we want to do so that we can tolerate the amount of people coming into it, so we're kind of controlling the flow, but really any team can come use TypeScript now. We're going to remove the whitelist sometime in the future this year. The benefits that we sold this on at Google, first of all, we talked about inline types. Easier to read, easier to write. We've built some infrastructure around it, so we have very fast recompile times. So I get all the benefits of type checking, finding bugs as I'm typing the code, rather than waiting till later. And that I can edit and see those edits in my browser in about a second for most teams. Then we have these decorators that are part of ES 2015. We can express nice things about Angular and metadata about other things we want to do in JavaScript. We built tooling so that it would be closure compatible. So all of the teams who had built in closure-style JavaScript could start integrating this a little bit at a time. You didn't have to do a big bang migration. That we had IDE support, and this is not something we did, although we did build support for our own internal cloud-based editor at Google, but all of the other editors that people use just come with TypeScript support. We also, since TypeScript is statically analyzable, we were able to build tooling to automatically write the build files. Not a fun task, automated it so nobody ever has to touch those things. We talked about the automated conversion tools to make it easier to migrate your Clojure code to TypeScript. And it was actually a big deal for the committee that there was a vibrant community around TypeScript outside of Google, so it wouldn't be just a proprietary technology. A language is a big deal. We didn't want to have something that was just owned by Google. Okay, so here we are, April 2017. We get to check the TypeScript box, but not the CLI box. Let's talk about why. Outside of Google, there's a whole bunch of tools that you're probably familiar with. Things like gulp, grunt, uglify, rollup, webpack, for doing various things in the build and optimization steps in shipping software. We don't use any of those things at Google. I know, shocking. And there's nothing wrong with these tools. It's just that we built our own versions of these things. We'd use something called Blaze for build and Clojure for types and optimization. We built them before any of these other tools existed. And so there's just a lot of momentum behind them. There are open source versions of both Blaze and Clojure. Clojure, of course, supports JavaScript, has gotten some uptake. Blaze, not so much, though. Externally, the open source version of Blaze is called Bazel. You move the letters around, you get Bazel. It has some wonderful properties. It's incredibly fast. They parallelize the builds for just about the fastest turnaround that we can imagine. It's incredibly scalable. At Google, we build the biggest software projects anywhere on Blaze. Same software on Bazel. Incredibly flexible. We build multiple languages, not just JavaScript. The only problem with Bazel is to date, it has not really had good or really any support excuse me, for JavaScript externally. I'll let you go read more about the benefits at bazel.build. But we'd like to see if we can change this. And so we have this new project inside the Angular team called ABC. And if you hear us talking about it, ABC just means Angular with Bazel and Clojure. And using Clojure as an optimizer, not as the type checker, still using TypeScript as the type checker. We're going to start doing this for Angular Core. We want a lot of those speed and reliability benefits that we get with Bazel. We're going to do it on the core. And for anyone contributing from the outside world, you can start seeing how this is going to work. We're then going to move it to the Angular material project, make it work there. And there's some folks, mostly big companies, who want to get these same sort of big scale and performance benefits that we do at Google that want to work with us as early adopters on this. Since it's never been done before outside of Google, working with JavaScript projects and Bazel, there's a lot we need to understand. We're kind of limiting our roadmap till there until we get these steps worked out, and then we'll figure out what we want to do going forward. But all of this, you're going to keep seeing us try and move our worlds closer together between the outside world and the way we do software at Google because of all of the benefits that I talked about previously. All right, thanks so much. I'd like to bring Rob WORMALD up to the stage to talk about how we see people using Angular externally.
Hey everybody, I'm Rob WORMALD. I'm one of the developer advocates on the Angular team here at Google. And today I wanted to talk to you a little bit about, we keep using this word platform, right? The Angular platform, the Angular platform. I get asked all the time, isn't it a framework, not a platform? So I wanted to talk to you a little bit today about what we think about platform, what I think about it, and kind of some of the ideas we have for the future. So, as I do, because I work at Google, I Googled it first, right? And so you get these two answers that pop up. And this first one is a raised level surface on which people or things can stand. And initially I thought this was a little strange, but when you look at it, this is more or less exactly what Angular is doing, right? We're taking the browser, we're giving you a nice smooth surface on top, we're kind of elevating you above, we're getting you internationalization, animation, routing, things like that. So this definition actually kind of works for me. The second one is a declared policy of a group, and this is maybe even a little bit stranger. But actually, Igor talked about this on the day one keynote, right? This is our policy, this is our platform. We want to have apps that people love to use. We want to have apps that developers love building, and of course, we want to have a community where everyone feels welcome. This is the one I want to talk to you about today, apps that people love to use. Because this is why we do what we do, isn't it? Now, when I started at Google as a noogler, this is like the very first thing you get told, right? You get your badge, you get your photo taken, and then you have to sign a piece of paper that says, I'm always going to use data to make decisions. It's not actually true, but this is how I think about it. So, how do we measure love, though, right? How do we measure how much users love these applications? This is hard. We thought about this for a while. But luckily, we have a whole team at Google who does this, right? DoubleClick, ads, all of these people, this is what they're thinking about. This is how we make money. So they give us a couple of really, really interesting stats here. The first one, more than half of visits to a mobile website are abandoned if it takes more than 3 seconds to load. The second one is that 50% of people expect a page to load in less than 2 seconds. So these are big targets, right? So how are we doing? How is the web ecosystem as a whole doing at these sort of metrics? Well, if you go a bit further in the DoubleClick study, the answer is really not very well at all. So these are two very scary stats for me. More than 3/4 of mobile sites take longer than 10 seconds to load. So again, 3/4 take longer than 10 seconds. Half of the people leave if it takes more than 3 seconds, right? We're losing some users. That means probably users that are not loving our applications. This one at the bottom here, I'm going to call this out. The average mobile website takes 19 seconds to load on a 3G connection. 19 seconds. Anybody have any idea how long 19 seconds is? That was 10 seconds. So, not great, right? Now, by comparison, if you get this right, and so we sort of define getting this right as getting your page up and interactive in under 5 seconds. Most of these sites see way better stats, so longer average sessions, lower bounce rates, and if they're showing ads, big boosts in actual ad viewability. So these are real important things, real business metrics that really, really matter here. So, apps that people love to use, how do we do that, right? John Papa would say, just use the force. Easy, right? Some people would say, don't use a framework, right? Why would you use a framework? Just write a website. Just artisan handcraft, hand roll everything you do. Well, at Google, we like to say the whole point of delivering frameworks, the whole point of frameworks is to make delivering great things easy, right? And Brad just talked about why we do that inside of Google, enterprise applications. All of this stuff that we use, the things that I use to get paid at Google, right? That's what we use it for. But in my job as a DA, I talk to all kinds of people who are doing things way outside of the norm of what we're doing internally at Google, right? And this is what we're talking about with this platform. We begin to see that people are starting to push the boundaries of these things. So this one was our kind of primary focus when we started with Angular, right? So we want to have interactive apps that are really, really reliable, really, really fast on mobile. This has been a big focus for us for a long time. But also, increasingly, we see sites that are doing things like mixing static content and highly interactive components. And at the other end, sites that are doing really content first. Maybe they're not interactive. Maybe you're a news. Maybe you're a blog site, right? And these are use cases that initially we didn't really consider, or we considered but we didn't focus on, because again, at Google, our thing is really this enterprise sort of internal behind the firewall app, right? But we keep hearing from developers, hey, I wish I could use the skills that I have as an Angular developer, building interactive apps to do all the other stuff I have to do, right? It would be nice to not have to use WordPress or Java or .NET and JavaScript on the front end, right? What if we could use Angular to really handle your entire web presence? And make it easy for you, right? If you don't have to know 6 different technologies, if you're an Angular developer, we can make you that much more productive and make it that much easier to build really powerful apps. So we thought about this for a long time. This has been an experimental project for some time. You may have heard of it as Angular Universal previously. Jeff Welpley, Patrick JS, there's been a huge amount of people who've helped with this project over the past 6 months to a year. And before we came to Angular 4, we wanted to make sure that we had a really nice, solid thing that we could use and we could begin to spread out to the community. So this is Platform Server. So Platform Server gives us a whole bunch of different options, and I think the easiest way to understand what it is and how it works is to kind of go through some of these use cases, right? So let's start with the case that this is probably relevant to almost everybody in this room, right? You are always wanting to have faster apps. Nobody wants to have slower apps. That's not a feature. So this first one I think is a broadly applicable use case that should work for almost anybody. So this is the app shell idea, right? We talked about this at I/O. We talked about this at ng-conf last year. The idea of the app shell is that we want to take an application like this, right, that has it has a nav bar, it has some sort of Chrome at the top, and then we've got this interactive content in the middle. What we want to do is move this over to using Universal, to using Platform Server. So what we can do is actually go ahead and render it on the server before we send it out to the client. And in the case of the app shell, we're going to go ahead and render that at build time, right? So we're just going to use Gulp or Grunt or Webpack or whatever, and we can run it through our new platform server and kind of take a snapshot of this page. So we're going to take a very simple existing app here. This is a new method that's been added to the browser module here. And this basically just tells Angular, hey, I might actually go ahead and render this on the server. I might render this at build time. And really what this links up is things like making sure CSS works properly when we pre-render on the server and then move it over to the clients. This idea of transitioning between the server and the client is a very, very difficult thing to do. So the idea of this is that we want to make it as easy as possible to link up kind of the server and the client way of doing things. So this is what we want to render, right? The app shell, we want to render this outer nav bar, this outer toolbar, maybe the side menu. but not really load in any of the interactive content. And we do this because if we can get this piece rendered without any JavaScript, without waiting to load anything, that user has an immediate impression that your application is up and running, right? They're not sitting there waiting on that white screen for 19 seconds, right? Waiting for something to happen. So this app shell idea, what we're going to do is we're going to render this outer container on the server at build time, and then go ahead and boot our app as normal. So this is my sort of basic client app. You've probably written one of these already. And I'm going to go ahead and create a new ng module here. We're going to call it my server app module. I'm going to import my original one there. And I'm also going to go ahead and import this new server module from Angular Platform Server. So the server module does a couple of things. For example, if you're using HTTP in your client's app, the server module will go ahead and give you a server-side compatible version of HTTP. This means if you're making HTTP calls inside of your app, they will go ahead and work exactly the same in Node. We're going to then actually import the app module that I created, and I'm going to tell it to bootstrap this my component. And then we're going to create a new main file. So this is like the main file you would start up in your client-side application, right? On the client, you would bring in your platform browser. On the server, we're going to bring in this new render module factory function. So this works almost exactly the same way as your bootstrap module factory function does on the browser, except that, of course, we're not running in the browser, right? So we don't have a DOM to talk to. And so the way this works is we're going to tell Angular, number one, here's the document I want you to use, right? So I'm going to read the file off disk here. You could generate this from HTML. Effectively, we're just going to give Angular a string that represents the HTML we want to render. And then we're going to give it a URL. And this is a little bit interesting. Again, we're not running on the browser, but of course, Angular has a router, right? It understands URLs. So we can just tell Angular, in this case, well, I want you to load the home page because that's the thing we want to snapshot and render. So we render the module factory. We pass in our compiled, my server app module ng factory. That's a really long name. I should have made that a bit shorter. So my server app ng module factory, and then we pass in the document and the URL. And what we get out is basically this rendered HTML. And that's literally just a string that is the HTML you would see if you were looking in the DOM. And at this point, we can do whatever we want with it. So the first thing I'm going to do here is I'm just going to write it back to disk as appshell.html, right? And now I've got this instead of using my sort of empty index.html page, I've got a pre-rendered container that I can then serve the rest of my application into. So this is really simple. We've prototyped the app shell idea before, and I think we're going to go ahead and look at making that a first-class thing again. But we really wanted to wait until we had a really nice, solid core to build that on top of, right, before we fully supported that. So now we have that core, and it opens up a bunch of really new ideas. So what you get is an effect like this, right? And I'll show you that again. So what you see is the outer container. Oops, let's reset. What you'll see is the outer container sort of render. It takes a second, and then the rest of the sort of interactive application boots up. So you can see it there, and then the interactive app boots up. And that, again, lets your users know, hey, things are up and running, stuff is happening, don't run away, we're about to be ready to go. This gets even better if you start using Angular's service worker implementation, right? So the app shell and the service worker model work really, really well together. So you go ahead and statically cache and install with a service worker this app shell container. It'll work offline. It'll work if you're on a poor mobile connection, because instead of going out to the network to fetch this, we've got it installed locally on your device. So again, the performance here is almost instant. This is, as I said, I haven't yet come up with a case where this is not a great idea, right? This is something that almost everybody can be using today. Service worker and app shell work beautifully together. We've just released our new version of our Angular service worker integration. This handles things like offline caching, dynamic caching of content, push notifications. Eventually, we're looking into things like pushing updates to your application out to the browser. So we think this app shell plus service worker idea works really well for almost every kind of interactive enterprise app you'd be building. Mobile apps, whatever you want to do. So this is a little bit different though, right? Most of you are building interactive apps, but we hear a lot about mixed content sites, right? Things that are not traditionally apps, applications. And a good example of that's the Angular website, right? The Angular website there's a lot of static content, right? You want to land on our home page. We've got a list of events. We've got a list of features. And then we've got a much more interactive docs section, right? We've got search in here. We've got all kinds of, interactivity as you move around. And so sites like this historically have been tricky, right? Because you want to make sure that A, you want to see people who are coming to see your static content, right, shouldn't have to wait to see that dynamic content, right? Or shouldn't have to wait for the dynamic content before they can do anything. So we can solve this as well with Universal, right? So this is a very, very simple Express-based application. So what we're going to do here is, instead of pre-rendering this at build time, what we want to do is every time somebody comes to visit our website, we want to go ahead and render the appropriate page that they're visiting back out to them. So this code looks almost exactly the same as the app shell case, except there's a little tweak. So we're going to go ahead and start an Express app server. We're going to go that same thing and load our index.html page. We're going to go ahead and wrap our render module factory function in a render module factory function in a nice little render method here. And like every standard Node.js Express-based server, this takes a rec and a res, right? A request and a response. So what we're going to do is go ahead and say, if I ask for app.use/render, or basically any route, I can add all my routes here. I boot up my server. And what happens is each time somebody hits my website, instead of using the homepage URL, you can see there I'm actually getting the URL from the request. Interestingly, Angular's router works exactly the same on the server as it does on the client. So this means that you can visit, you get the appropriately rendered page if you're doing things like search results, or you're doing product listings, or anything to do with SEO. This works amazingly because you get the exact page the user requested, and then the app can boot up in the background. So we just res.send response. This is, I think, the case that most people who are doing these sort of mixed content sites will end up using. This sort of, before we moved forward with the platform server project, this was kind of rolled under the Angular Universal umbrella, right? So the Angular Universal project will continue, and really what we want to see is things like this Express integration be built in the Universal world. So the Angular team will support this platform server kind of core API, and then we hope that the community builds amazing wrappers like this to do all kinds of crazy things. So speaking of crazy things, right, let's go a little bit further with this. So content-first sites, and to me these are things like, the New York Times is a content-first site. News, blogs, these things are very much, they're designed to be read. They're usually not that much interactivity in them. And so here it's critical that you get content on screen as quickly as possible, right? Ideally, maybe you don't need JavaScript at all to do this. That's a really strange thing to say at an Angular conference, right? But maybe you don't actually need JavaScript to render this page in the browser. So Google's been investigating this idea with AMP pages, right? AMP pages are this new idea where really Google has defined a set of very, very restrictive rules on what you can do in a website. And the idea of this is that if you opt into following these rules, and there are things like, you can't load a whole bunch of JavaScript, you can't have images that are going to make the page all janky. There are rules to promote a superior experience. So the other really nice thing about AMP is if you opt in and you do these rules, then you get to show up in things like the carousel at the top of the page, right? Now, if you're an enterprise developer in this room, you're saying to me, who cares? This is unimportant. I don't want to show up in search results, right? But I've talked to a lot of developers as a DA that this matters, right? This is hugely, hugely important. And so why can't we do this with Angular, right? We're able to server-side render. We don't need to run JavaScript in the client if we don't have to. We could do AMP pages this way, right? Why not? It would be easy to do. And we've prototyped this before. I built a couple of demos. And if this is something you're interested in, if this is something that you want to pursue, come and speak to me after the talk, because we'd love to hear what you'd like to do with it. Now, static content, no interactivity, no dynamicism. You can't do commenting. AMP is very, very restrictive. What about AMP plus perhaps a progressive web app, right? What if we could get the best of both worlds? What if somebody could come to your website, have an amazing first experience, right? The second they get to your site, they have instant content they can read, it's beautiful, it's fast, it's not janky. And then if they decide, hey, I really like what you're doing here, and maybe I want to participate, maybe I want to comment, maybe I want to get more involved, well, then we need interactivity, right? Then we need an app that's going to actually engage with the user. So progressive web apps are about that, right? We've been talking about for a year. Push notifications, service workers, all of these things that make really, really interactive websites. So if we combine these two pieces of technology, it looks something like this. First, We want to build this AMP page. We can render that with Angular on the server. We can cache it out to a static file server. Google's cache will pick it up. We'll put it in Google's CDN for you, so it's instant fast. The one exception to the you can't run third-party JavaScript in AMP pages is that you can run service workers. So the trick is, we go ahead and install your AMP page, or we go to your AMP page, and in the background, while the user is scrolling through the app, we will go ahead and install our service worker in the background. It will go ahead and pull your entire application down from the server. It will cache it. It will keep everything ready to go. And then if the user decides, hey, actually, I want to comment on this article, I want to engage, I want to plug in, we can then basically instantly boot that app. And instead of going, again, all the way back to the server, inside of the service worker, we can intercept this request and basically then put the user straight into a highly interactive environment. So this, I think, is going to be a really, really cool thing, and really, I think, is the best of both worlds. For me, it's like the holy grail of doing web development, right? There are very few trade-offs here. You get really the best of both worlds, really fast initial experiences, and then the interactivity that we all use Angular for, or Angular 2. So these three things, right? Apps that people love to use, apps that developers love building, and a community where everyone feels welcome. This slide popped up on Twitter last night, this "You Can Build With Us." And for us, this really summarized what this is about, right? We want you to jump on the Angular platform. We've opened up a huge amount of new ideas, a huge amount of new avenues we can follow. And so please, please, come and build with us. And if you want to do any of this stuff, again, please come and talk to me after the talk, and I'm quite happy to run through it with you. So that's everything from me. Thanks very much for coming.